Alright, so I'll be going over the assignment for topic 7. So the data set that I chose were Antarctic penguins and the various characteristics of these penguins. The one I'm looking at would most in this test or these tests will be the flipper lengths and also the species of the penguins and their body mass. So for the first test, I did a ANOVA one-way test. So we're looking at how the flipper lengths of the penguins differ amongst the three species. Sorry, I didn't memorize the name of the species. So there is the Adelie penguin, the chinstrap penguin, and the Gentoo penguin. So first, I also wanted to do a Levine's test and a Shapiro-Wilk test because there are some assumptions with using these types of tests, the one-way ANOVA and the linear regression model. So we do require that there is equal variance across the species. Across the groups. And then for the normality, we also want to check to make sure that it is normally distributed. So I did the Levine's test, and then based on those results, we either fail to reject the null hypothesis that the variances are equal across the species, or we will reject the null hypothesis, and that at least one of the species has a different variance. Now for Shapiro-Wilk tests, our null hypothesis that the flipper lengths are normally distributed, and that the alternative hypothesis says that it's not normally distributed. And then I also did a violin plot, just so we can help visualize, as you'll see in a second, why. So we found that the p-value for the Levine's test was 0.718, greater than the 0.05. Therefore, we failed to reject the null hypothesis, and there's in fact equal variance. And then for the Shapiro-Wilk test, for normality, that was done for each of the three species. And two of the species, the Adelie and the chinstrap, had p-values of greater than 0.05. Therefore, we failed to reject the null hypothesis for both of those, that there's in fact normal distribution. However, for the Gentoo, we found that a p-value much less than 0.05, which is our significant value, and that therefore we reject the null hypothesis that there's not normal distribution. And we can kind of see in the violin plot. So you should have these violins be symmetrical. However, for the Gentoo penguin, which is the one that was found to be not normal, you can see that there is an additional little bump here, making it having some skew. And then for the ANOVA test, we found a p-value of much less than 0.05, and therefore we would reject the null hypothesis that in fact at least one of these groups has a different average mean compared to the others. Again, you can see that with this violin plot how they're not equal standing. However, like I said before, we can't tell which one specifically until we do a further test. And that would be like the Tukey's range test, which is done in the one of the later sections. And then now going over the multiple for the single variable model, I did the flipper length as a independent variable, and then the body mass is the dependent variable. So we're saying that the body mass depends on the flipper length. And so in order to do this, again, there are assumptions that we need to check with the Shapiro-Wilk test, and then also the Bruch-Pagan test. So the Shapiro-Wilk test is for normality, and the Bruch-Pagan test for homoscedasticity. And then we also want to look over the results of the generated model, and then look at the plots of the predicted versus actual, and then also the residuals. So looking over the linear regression model results here, we can see we have a very low probability statistic, which is found here for our F statistic, and then we also have the coefficients, and we can see that the flipper length does have a less than 0.05 probability, indicating that it is useful for predicting the body mass. And then also the omnibus and then the screw are also useful values to look at. And then we also get a warning from Python that one of the condition number is large, indicating that there might be strong multicollinearity. And also we can look at the predicted versus, well, I'll go over this in a second. First, I want to look over the R squared value, which was 0.759 in this table here, indicating that 75.9% of the variation in the body mass is explained via our model. And then, like I said before, the F statistic had a very low significance. Very low probability statistic, which is much lower than the 0.05 significance level. This means we should reject the null hypothesis that our predictor flipper length has a significant linear relationship with the body mass. And then the omnibus was 5.634 and the probability of 0.06, indicating that the residuals are normally distributed. And then looking at these graphs here, we can see how there is a, looking at the actual body mass versus what we predicted. And this red dotted line is what the ideal way it should look. And we can see how our data points are all clustered around this line, indicating that it has actually a good fit. And then looking at the residual plot, we can see a random scattering around the 0. This indicates that because we don't want a pattern, this shows that it confirms that the data that there is a homoscedasticity, and again that was found via our test, the Bush-Pagan test, which tests for the normality. The homoscedasticity, and that's with our p-value of greater than 0.05, which means we failed to reject the null hypothesis. There's constant variance. And then the Shapiro-Wilk test was 0.11 for the p-value, indicating we should fail to reject the null hypothesis that the residuals are normal. And so I went into further depth of these results. However, I'm much past my time already. So the only difference that I did in the next task was I did a Tukey post hoc test to see which of these groups had a different, because we did find earlier that from the ANOVA test that one of the means was different, and then looking at the results from this test, that we should reject for each of the pairings or each of the comparisons. In fact, each of them all have a different average mean difference. I'm sorry, an average difference amongst the flipper lengths.